My project for the summer was to use confocal microscopy for the characterization of spontaneous emission by quantum light sources. I worked in the Charles Fabry laboratory at the Institut d'Optique under the guidance of Professor Benjamin West. My task was to build a small platform dedicated to the study of quantum light from defects in solids. Sounds cool, right? Let me show you. The study of atomic systems in solids is of great importance to their potential application in quantum technology. One material with such potential is hexagonal boron nitride. Our aim is to study point defects in hexagonal boron nitride. This is an emerging two-dimensional material in the area of quantum photonics due to its large bandgap. Point defects in solids can strongly affect its electrical and mechanical properties. Something interesting about these point defects is that they can behave as single photon sources. To do this, we'll be using confocal microscopy. This is based on fluorescence. So if you shine a light on some molecules, you may see a light of a different color emitted from these molecules. This is known as fluorescence. The molecule will absorb high energy light, which will increase the energy of the molecules. Some of the energy from the photon is lost internally, and the molecule then will emit a photon with less energy. The excitation light wavelength and its color depend on the material. So based on this idea is how my platform was assembled. One advantage of using a confocal microscope is that we can do some scanning on any specific area of a material. Here's how my setup looks. We have a collimated laser as our excitation source. When our sample is excited, it will emit some light. The fluorescence light will be collected and directed into the spectrometer to study the spectrum of the emitted light. I would like to thank the Plasmonics and Quantum Nanophotonics group for their help throughout the summer, the University of Michigan for organizing this amazing program, the Institut d'Optique for hosting me, and the National Science Foundation for all the support.